Ladies and gentlemen, it's an honour and a privilege to be able to give the opening address at this conference. This is the latest of 4 conferences that I've organised on health and the environment, and the third to be held at RIBA. The first RIBA event was on the subject of lead in petrol and was organised in 1982 on behalf of CLEAR, the Campaign for Lead-Free Air. This conference led to the introduction not only of unleaded fuel, but also catalytic converters, not only in the UK, but throughout the European community. The second RIBA event was in 1988. The topic then was ozone depletion. But interestingly, we included a section on climate change. The government listened on ozone and signed the Montreal Protocol, but they didn't listen about global warming. The CFC substitutes, which have been used worldwide, are all potent greenhouse gases. So the UK government, the EU and the UN jumped from one environmental problem straight into the arms of another. If anyone's interested, I've made a film about this in 1993, and you can watch it during the lunch break. So during the 1980s, I was heavily involved with environmental issues. First as medical scientific advisor to CLEAR. Later I was chair of the Pollution Advisory Committee at Friends of the Earth. I should hasten to add, however, that this was not my job. It was, if you like, a hobby for which I never got paid. By profession, I'm a consultant dermatologist, and for 10 years I was director of the skin tumour unit at the Institute of Dermatology, which is now located at Thomas's Hospital. I retired from the NHS in 2008. So despite the fact that I was heavily engaged elsewhere, we, that is CLEAR and Friends of the Earth, won all 4 campaigns in the 1980s, and we won them in the teeth of opposition from the industries concerned and against the wishes of a Conservative government with Maggie Thatcher at its head. In order to buttress these campaigns, in order, if you like, to provide the scientific bedrock on which these campaigns could operate, I organised 3 international conferences in London and subsequently published the proceedings. Does this work? Okay. The first was Lead versus Health, Sources and Effects of Low-Level Lead Exposure, co-edited with Sir Michael Rutter, who was Professor of Child Psychiatry at the Institute of Psychiatry. The second was Radiation and Health, Biological Effects of low-level exposure to ionising radiation, which I co-edited with Sir Richard Southwood, who was Professor of Zoology at Oxford University. He'd formerly been chair of the Royal Commission on Environmental Pollution, but more importantly at the time of writing, he was chair of the National Radiological Protection Board. Finally, Ozone Depletion, Health and Environmental Consequences, published again by John Wiley in '89 and co-edited with Professor Tom Wigley, who at the time was head of the Climatic Research Unit at the University of East Anglia. And that, of course, should ring a few bells because it was the same unit that was targeted by unknown individuals from the east coast of America in November 2009 in an attempt to sabotage the Climate Change Conference in Copenhagen in December 2009. What is very strange about that event is that the emails were released 1 week before Nigel Lawson launched his think tank, the Global Warming Policy Foundation, and one wonders if he knew in advance that the emails were coming. I did ask him, but he never replied. So here we are at the Ozone Conference in 1988. On the left, just peeking into shot, is John Pyle, who was responsible for satellite monitoring of ozone in the Northern Hemisphere. On my left is Joe Farman, the man who first discovered the ozone hole over Antarctica in 1983 using ground-up observations. And on my right is Bob Watson, who was then head of satellite monitoring at NASA and confirmed Joe's observations by making space-down observations. Bob Watson is now Professor Sir Robert Watson, FRS, HMG Advisor on Climate Change at DEFRA, and former chair of the Intergovernmental Panel on Climate Change. And he might have been IPCC chair for longer had not the White House opposed his reappointment under pressure from Exxon. As I mentioned, when we organised the Ozone Depletion Conference, we had a section on climate change. One reason is that global warming aggravates ozone depletion, The other reason is that CFCs that deplete stratospheric ozone are also powerful greenhouse gases. The solution the industry came up with was to substitute CFCs with HCFCs and HFCs. They of course do not deplete ozone, but as we warned at the time, they're still powerful greenhouse gases and are not therefore suitable substitutes. The government of the day accepted CFCs had to be banned, but sadly they ignored our advice on the substitutes, and today we still have a major problem as HCFCs and HFCs are still in widespread use. I talked to John Pyle about this recently and asked how come these substitutes are still being used after almost a quarter of a century. And he said you have to realise what happens when you go to intergovernmental meetings where these issues are discussed. First of all, the scientists are only allowed to talk about the science. They're not allowed to say what they think ought to happen. That is left to other people called politicians. Secondly, if you're discussing the Montreal Protocol to ban CFCs, you're not allowed to discuss the Kyoto Protocol in the same room. So if you bring up the global warming potential of HCFCs and HFCs when you're discussing ozone depletion, the Chinese delegations say, wrong protocol, we're discussing Montreal, not allowed to discuss Kyoto. So back in '88, when we held a conference at Reba, the person who I invited to chair the session on climate change was Sir John Maddox, FRS, who was then the editor of Nature. In fact, it was his second stint as editor of Nature, and he was known to be quite pro-nuclear, so I was slightly anxious about inviting him to chair the session. However, I need not have worried, as he gave what I regard as one of the most far-sighted and perceptive statements on climate change. Incidentally, this is all available on the Help Rescue the Planet website. So Maddox said as follows. Remember, he was here on the same spot in 1988. He said, before introducing the first speaker, I'd like to say a few words about the subject of this afternoon's session, global warming. I wish to clarify my own position on the issue, not least because in the past I've sometimes been accused of being less than friendly towards environmentalists and the issues that they espouse. However, the greenhouse effect is an issue that we ignore at our peril. Certainly it is a field in which there are many uncertainties which are unlikely to be resolved quickly. Even so, it is exceedingly unlikely that the accumulation of carbon dioxide and other gases in the atmosphere can continue as it is at present without at some point there being climatic change, the end point of which may be the melting of the ice caps. It is my opinion that this prospect is so serious that whatever the uncertainties in the scientific predictions, it is essential soon to work out a framework in which it will be possible at some point in the future to control the way in which carbon dioxide and other gases are allowed to accumulate in the atmosphere. In many ways, the Montreal Protocol is a valuable precedent for the kind of convention that would in due course have to deal with greenhouse gases. Obviously, the problem of global warming has much greater implications economically. Even so, despite the uncertainties that exist, it is by no means too soon to begin embarking now on the negotiations and the kind of agreements that will be necessary to regulate the greenhouse problem. Of course, this may prove quite difficult. In my view, Maddox's only error was to underestimate the difficulties that would be encountered persuading countries to sign, particularly the big emitters such as the US and China, and those with huge vested interests in the continued burning of fossil fuels such as Canada, Saudi Arabia, and the oil-rich states. However, international negotiations began well, and in 1992 the Earth Summit in Rio published the following declaration by the participating countries. The ultimate objective of this convention is the stabilization of greenhouse gas concentrations in the atmosphere at a level that would prevent dangerous anthropogenic interference with the climate system. However, the agreement was never really implemented. Despite the Kyoto Protocol and the best efforts of the United Nations, annual emissions of carbon dioxide worldwide have risen by 49% since 1990, which is the baseline year for the Earth Summit and also the baseline year for Kyoto. By any standards, that is a spectacular political failure. The deal recently thrashed out at the UN conference, COP17 in Durban, South Africa in December 2011, allows the major polluters, China, the US and India, to continue emitting carbon without any restrictions whatsoever until 2020 at the earliest, by which time it'll be game over and irreversible climate change will become unavoidable. And as Maddox clearly foresaw, when the Greenland ice sheet melts, world sea levels will rise by 7 metres, and when the western Antarctic ice sheet melts, sea levels will go up by a further 6 metres. And of course this is already starting to happen. Here we have a satellite view of Greenland, in which ice loss is located by colour, red indicating rapid loss, and you can see that Greenland is already starting to fray around the edges. Here we have a satellite view of Antarctica, and you can see that the western Antarctic ice sheet is not just fraying, there's widespread loss of ice, and that is particularly worrying because the WAIS is located on land that is sited below sea level, so once the seawater gets underneath the ice, it could disintegrate quite rapidly. So 6 metres from the western Antarctic ice sheet and 7 metres from Greenland makes 13 metres, which is 43 feet, and Windsor Castle is only 50 feet above sea level. Even Nigel Lawson will notice that. Well, actually he won't, because he'll be dead. But the round tower at Windsor is 800 years old. After another 800 years, you'll be able to paddle round the tower unless we get a grip on this issue. One more thing you need to be aware of: tipping points, the phenomenon by which positive feedback mechanisms suddenly make a bad situation very much worse. There are lots of positive feedback mechanisms with climate change. The albedo effect, whereby loss of reflectivity from the Arctic ice leads to greater warming of the oceans, is a well-known example. But there is also the destruction of rainforests. What can happen with the Amazon is that instead of being a net absorber of CO2, it can become a net emitter, and then climate change accelerates quite quickly. But the most concerning of all is the methane locked up in the permafrost at northern latitudes. By 2040, the tundra will have released the equivalent of 45 gigatons of CO2 equivalent. Global emissions of CO2 are currently 10 gigatons annually, so this will hugely accelerate global warming. By 2300, the tundra could release the equivalent of 800 gigatons of CO2 in the form of methane. If the permafrost of northern Canada and Russia releases its methane, then it is game over for human civilization, and we can all start building an ark. Methane, by the way, is the greenhouse gas that is shale gas, the fossil fuel released by fracking. In retrospect, it was possibly over-ambitious of the United Nations to try and reach unanimous agreement involving 194 nation states on legally binding measures to mitigate climate change. The Montreal Protocol was successful because readily available substitutes for CFCs were available, even though they used the wrong ones. The situation with climate change is more complex by an order of magnitude. Even so, the alternative technologies are there. It just requires political will for them to be implemented, and any international agreement must allow individual countries to achieve their reduced carbon target by whatever means they deem appropriate for their country. Science has taught us about the complexity and the resilience of the planet, but also the vulnerability of individual species. Darwin gave us a blueprint for how life on Earth has evolved, even though the Tea Party in America seemed to have enormous difficulty with the concept of evolution. It is unlikely that any species is immortal, and that includes man. Even so, there is no need for any species to commit suicide, and that is what we seem to be doing with global warming. What do we know about the Earth? What do we really know in terms of truly fundamental facts? Well, we know the circumference of the Earth, because that was discovered in 270 BC by a Greek, Eratosthenes, living in Egypt. How did he do it? Well, it was dead simple, really, but it was also rather brilliant. Eratosthenes found a well in southern Egypt, which was located exactly over what we now call the Tropic of Cancer. That meant that on Midsummer's Day at noon, the sun shone directly down the well. He simultaneously put a vertical staff in the ground in Alexandria, and he measured the angle that the sun's shadow made with the staff. The result was 7.5 degrees. The distance between Alexandria and the well was 5,000 stads, so he knew that the circumference of the Earth was 5,000 stads times 360 over 7.5. The result he came up with is about 40,000 kilometres, which is very close to present-day calculations. The second important fact is that the Earth is not the centre of the universe or even the solar system. We know that the Earth goes round the Sun and not the other way round. In fact, the Greeks knew that. It was called the Solian version of the solar system, but it was not until Copernicus and Galileo started observing and writing that the Solian view was vindicated and the Ptolemaic version was rejected. Here we have a page from Galileo's notebook, where he looked through his telescope on successive nights and saw these little dots going around Jupiter and realised that Jupiter had 4 moons and not everything in the solar system was going around the Earth. The third thing we know about, incidentally, that view of the universe that the Earth goes around the Sun was not accepted by the Catholic Church until 1992. The third thing we know about the Earth is its age. We know this because of a remarkable man called Patterson, who I think deserves to be recognised as the most important scientist of the 20th century, along with Albert Einstein. Certainly he was one of the greatest researchers the world has ever produced. He worked initially on the Manhattan Project. He was an expert in isotope dilution mass spectrometry, and his job was to separate uranium-238 from uranium-235, which is the fissile material used in bombs. He was horrified by what happened in Hiroshima and Nagasaki and devoted the rest of his life to research that would enlighten or improve man's understanding of the planet. The first task he was given was to date the age of the Earth using lead isotopes, and he did this by comparing the amount of lead-206 and lead-207 in an iron meteorite, which he took as the baseline age of the solar system. He then did the same measurements in a sample of modern rock from the Earth's mantle. The lead isotopes in modern rock result from the radioactive decay of uranium isotopes, which are abundant in the Earth's mantle. There are no uranium isotopes in an iron meteorite, so the lead content represents the amount of lead present at the birth of our solar system. Patterson knew the disintegration constants for uranium-238 and 235, what we now call the radioactive half-lives. So by comparing the amount of lead-206 and lead-207 in these two samples, as he put it, blip, out came the age of the Earth. This is the formula that Patterson used. I'm afraid it's not quite as straightforward as E equals mc squared, but it is just as earth-changing. Except it wasn't quite that easy. The lead isotopes in the iron meteorite were present in minute quantities so small they were overwhelmed by the lead contaminating Patterson's laboratory. Lead from petrol, lead in painted surfaces, lead in dust, lead used in the manufacture of glass bottles, laboratory glassware, lead in the water supply. All these sources of lead had to be eliminated completely before Patterson could do the crucial experiment. He had to build a lead-free environment from scratch. It took him 7 years of meticulous trial and error before he was able to prepare his samples. I now quote from a book by Sharon McCrane, Prometheans in the Lab. By 1953, Patterson finally had enough super-clean samples of primordial lead to calculate the age of the Earth. He took his precious samples to the mass spectrograph at Argonne National Laboratory, located in the midst of cornfields outside of Chicago. As he worked late into the night, the laboratory emptied and fell silent. When he finished his experiment and went outside under Illinois' star-filled sky, he knew after 7 years that meteorites, the Earth, and our solar system are all 4.5 billion years old, a figure that has never been challenged. When I met Patterson in '82, I asked him what that felt like. He said, well, I went outside and looked up at the stars, and I looked down at the Earth, and I said to myself, I know how old you are. What's more, I'm the only man in the history of the world who knows how old you are. That felt pretty special. And here we are, in 1982, at the time of the Clear Conference at Reba. On the left is the veteran campaigner Des Wilson, next to my late wife Annie. On the right is Herb Needleman, who did all the pioneering work on lead and children's IQ. And there in the middle, holding my wife's cat, Shu Ling, is the great man himself, Patterson. Our children, Joy and Christopher, are in the foreground. Once Patterson had his ultra-clean laboratory, he was then in a position to measure lead levels in pre-industrial samples, and so he was able to show, first of all, that lead levels in the environment had gone up exponentially since the introduction of leaded gasoline in the 1920s. Note the similarity between this figure of lead in samples from Greenland snow and the hockey stick figure that is so controversial in the climate change debate. There are hockey sticks all over the place in science. The second thing that Patterson was able to show was that modern man was very heavily contaminated with lead. Here we have what is known as Patterson's measles diagram, so this appeals to me as a dermatologist. The lead burden of a pre-technological person, as measured in skeletal remains from an ancient burial chamber in Peru, is represented by 1 dot, the figure on the left. A lead-poisoned individual with clinical lead poisoning is represented by 2,000 dots on the right. And a typical person living in 20th century America or the UK, their lead burden is represented by 500 dots. For no other toxin in the history of mankind has there been such a narrow gap between what is known to be typical and what is known to be toxic. So let's get back to climate change, because it all started with the Industrial Revolution in England back in the 18th century. You've got a film, Steve. Can you show the film? CO2 emissions? So this is CO2 emissions worldwide from 1750. And it does it geographically. We've got a little map of the world. And you can see there's not much happening in 1750 apart from a little blip in England. And you'll observe that nothing much is happening anywhere else apart from the United Kingdom for the first 75 to 100 years, which means that Team GB had a head start when it came to industrialisation. And it explains why Great Britain became great and why the sun never set on the British Empire. So 1/4 of the globe was coloured red when I was born, but that same year India became independent, and now India is so advanced it's got its own fast breeders and its own independent nuclear deterrent, and it's determined to emit as much CO2 as we do to prove that it really is as advanced as we are. So the consequences of releasing all that CO2 are fairly easy to predict. CO2 levels in the atmosphere have gone up from a baseline of 280 parts per million to the current level of 390, and the rate of increase is accelerating, so that currently levels are increasing by 2 parts per million per year, so that by 2040 we will have reached 450 parts per million, the level at which most scientists believe that climate change will become irreversible. The consequences of that are also easy to predict. CO2 is a greenhouse gas, traps heat in the lower atmosphere. The laws of physics dictate that that heat, that energy, has to go somewhere. Einstein's famous formula, E=mc², tells us that mass and energy are interchangeable, but it also tells us that you cannot make energy disappear. So obviously it warms the atmosphere, which warms the waters, which causes thermal expansion of the oceans, and sea levels rise. This is not rocket science. This is simple GCSE physics, and there's not a single reputable scientist in the world and not a single reputable scientific journal that disputes it. Here we have a temperature plot, and you can see that 1998 is one of the hottest years on record, but of course that was just an El Nino blip. Look at this graph, which shows mean temperature by decade. There's a steady and inexorable rise for each decade from the 1950s onwards. That is what we mean by global warming, and when Lord Lawson tells us that world temperatures have flattened off since the turn of the century, he's lying. Or since I'm not allowed to say liar, he's what we call in Wales a big fat sibber. What's happened to that? If atmospheric temperatures go up, then the oceans will eventually follow and sea levels will rise. But this observed increase is due to thermal expansion of the oceans, and it's fairly modest. Far more worrying is the melting of the ice caps, which transfer land-based ice in Greenland and Antarctica straight into the oceans. That produces a far more dramatic sea level change, enough eventually to do this. And I think even George Osborne would notice that. So who was the greatest scientist of the 20th century? Well, you cannot really compare Patterson and Einstein, because Einstein was like Mozart and Patterson was like Beethoven. One was a genius who created formula in his head and then just wrote them down. The other was an obsessional researcher who meticulously worked away at the task in hand till he came up with the truth. I think prize for third place must go to Joe Farman and his discovery of the ozone hole over Antarctica, the first recognition that man could fundamentally alter the composition of the atmosphere. Here I am talking to Joe Farman in 1993, and someone said it looks like you're explaining to him about ozone depletion. So these references deserve to be recognized as the three most important of the last century, and the last reference is the most important in this century. Peters et al., the publication that identified that global emissions of CO2 have increased by 49% since 1990. Forget the God particle. What matters is God's creation, which mankind is in the process of determinedly destroying. It is strange to relate that of the scientists I've discussed, neither Patterson nor Farman received the Nobel Prize. I suspect that Einstein received the Nobel Prize because his famous 1905 formula equals mc squared is more memorable than Claire Patterson's formula for the age of the Earth. However, I would like to reverse Einstein's formula to produce this variant, mc squared equals E, where m stands for multitude, that is world population, c squared is carbon per capita per annum, and E stands for extinction of species, or if you're the sort of person that doesn't worry about animals or plants, it's also the end of human civilization as we know it. At the UN Conference on Climate Change in Durban, South Africa, that took place in December 2011, the conference agreed that mandatory controls on emissions of CO2 would be agreed by 2015 and would take effect in 2020. Currently, China contributes 24% of world emissions, the United States 16%, and India 10%. So 50% of CO2 emissions worldwide are completely uncontrolled, and in the case of China and India, completely out of control. China is pushing for a renewable target of 15% by 2020, but it is also building one new coal-fired power station every week. When Chris Huhne came back from Durban, he said it was a triumph for European diplomacy. Maybe. From a political point of view, it was a shambles, and the point of view of the environment, it was an unmitigated disaster. Annual carbon emissions are now 40% higher than 1990, and emissions are rising by 5% per annum. This is only a triumph if your name is Nigel Lawson, Christopher Booker, or Matt Ridley, what we in the environmental movement call the unholy triumvirate. So why are we here today? Well, we're here to talk about science, and we study science to better understand the nature of things, and we do that because we want to make the world a better place. Claire Patterson put it more profoundly. Best scientists lack the comfort of peers. Their science is always first incredible, even though later it teaches more. Why do they struggle so? Because in each discovery of new knowledge lies an awareness of the beauty and worth of human life, which enslaves them as guardians of human destiny. To me, it's very simple. It's about the people we love and the gift of children. This is my wife, Nina, and this is my daughter, Lily. And there are no words to describe the feelings that are generated when you realize that the happiness of your child or their future security is under threat. You have to be a parent to truly comprehend, and if you are a parent, no words are necessary. Ladies and gentlemen, I'd like to hand over some more distinguished speakers. Thank you very much.